So welcome back everyone. Here we are going to talk about a new protocol called Carrier Sense Multiple Access with Collision Avoidance. Carrier Sense Multiple Access with Collision Avoidance is a network multiple access method in which carrier sensing is used. But nodes attempt to avoid collision by beginning the transmission only after the channel is sensed to be idle. So this is the key difference, guys. Make sure you remember it. Don't forget it. Collision avoidance doesn't want to continue transmitting a packet that it feels it's gonna collide. Once it senses collision, even before it senses collision, once it feels that there is a minimal probability of collision, it doesn't send. So carrier sense multiple is a network multiple access method in which carrier sensing is used, but nodes attempt to totally, completely avoid collision by beginning a transmission only after the channel sensed to be idle. It's why is that? Because it's practically important for wireless networks where the collision detection of the alternative CSMA CD is not possible due to wireless transmitters distancing their receiver during packet transmission. Another important point. So we understood what we mean by point number one. I don't want to experience any collision. That's it. This is my target. This is my goal. I cannot afford being like Ethernet wired cables. Experience collision and then cut my transmission, stop my transmission. No, I want to make sure, I'm a person who wants to make sure that if I want to transmit a packet, it's gonna go through correctly and successfully decoded by my receiver. I cannot handle any loss of my packet, and I cannot handle any collision, any corruption to my packet. Why is that happening exactly in wireless systems, so in Wi-Fi, wireless, mobile cellular networks? Because of this reason. In wireless transmission, the transmitters usually stops sensing their receivers during packet transmission. They just send the packet and then they don't listen basically back to what has the packet to what has the node to respond to the transmitter. They just send and then they don't listen back to what's going on with the channel. Why they don't listen back? Because the channel is wireless. Wireless is extremely noisy. There are thousands, millions of devices sending signals simultaneously at the same time. So there is no point. It's impossible basically to detect or sense during transmission. Especially after you transmit your data. So this is because of this property in wireless signals, collision detection is not suitable at all. I can only go with collision avoidance. Therefore, CSMA collision avoidance is also unreliable. Why? Because there are problems related to hidden node problem, exposed terminal problem, and the reason for that is because of the coverage area. Wireless, is more complicated than wired. The reason why wireless is more complicated than wired, because in wireless, your data, your signal is available everywhere around you. Basically, most of the nodes, usually they have omnidirectional antennas, and these antennas, they transmit signals in all the directions equally. And imagine any signal within the range of this transmission, it will be able to hear the transmission. And imagine each and every node in the network has this domain around it, this transmission range around it. For those of you who got antenna transmission system and they know how electromagnetic waves work around each antenna. For example, each mobile device you have, creating a wave around itself, and this wave is affecting maybe a certain range, and the wireless base station also has a range, and this range is affecting the surrounding around it. This is completely different than the case of wired, where your signal is confined and only available within the cable, within the medium, is not outside, is not everywhere. Therefore, collision detection cannot work in wireless. And to solve this problem, we came up with the collision avoidance. Researchers came up with a collision avoidance, but even then, collision avoidance is still unreliable. You might be still having problems related to something we call it hidden node problem and exposed terminal problems. Although this hidden node problem can be solved with solutions like request to send and clear to send, but still exposed node problems, exposed terminal problem is not easy to solve, and that you cannot all the time sometimes solve these things. So let's show you the hidden node problem and the exposed terminal problem, what they are and how they happen. So here we have two cases. On the left hand side we have the hidden terminal problem. On the right hand side we have the exposed terminal problem. So what does usually happen in the hidden terminal problem? You have three base stations, you have three nodes. Each node has a wireless transmission modem with an antenna, and this antenna is usually omnidirectional, transmitting in all the direction, and each one of these nodes has a certain range. When I put this range, this means that this is the range of the electromagnetic waves generated by the antennas or by the node. This is how far they can reach. This is how far they can sense. This is how far they can transmit. This is how far they can receive. This is what it means, this circle. And of course, this is hypothetical. In practical system, it's impossible to have it exactly equal from all the direction. Perfect circle. It's not like this, because in practical system, when you have a node, the node is surrounded by obstacles, buildings, trees, walls, whatever, objects from all the directions, and this affects your propagation. That's why usually it's not gonna have this perfect shape. But for visualization purposes and for understanding purposes, we are making it like circle here. So this is the coverage area of node C, the coverage area of node B, and the coverage area of node A. A is in orange and B in blue and C in cyan. So here B is a node in between two nodes, A and C. So A doesn't see basically C node, and C doesn't see A node, and in the middle there is B. So B thinks that it can talk to B. A node, it can talk to A directly. There is no other nodes is gonna access it or talk to it, or if it transmits, its range is gonna affect it. And C thinks the same thing because it's not seeing the coverage area of A. How would it know? How would it know? It doesn't see it, it doesn't feel it, it doesn't sense it. If it senses the signal with the higher power. The signal with the higher power is B. So if it sends a signal to sense, it senses B, the existence of B, it doesn't sense A. Therefore, since they don't know the existence of each other, they might send data simultaneously to the same node. And this is what will cause the hidden terminal problem. Basically, they will cause interference and collision at node B. At node B, you will experience severe interference and collision, and the data will be lost. For the exposed terminal problem here, you have overhearing. So A and B want to talk to each other, and C and D want to talk to each other. But like B, when B want to talk to A, C gets affected by this transmission. Yes, and therefore it makes it feel that the channel is busy and I cannot transmit, while it's receiving very little power here. That if C transmits, it won't affect B. But this is what's gonna cause the problem here, the exposed terminal problem, which is called overhearing. Of course, hidden terminal problem, you can solve it with request to send, clear to send protocol, but exposed terminal problem is difficult to send. Let's see why it's difficult to send here. So this is the range of terminal B. You have B, you have A and B and C and D, 4 nodes, 4 access points. Each one has an antenna transmitting wireless signals, and each one has a certain coverage area. So B is currently transmitting to A, and this is the range of B. And this is the range of terminal C. C wants to transmit to D, but it cannot send to D due to carrier sense. Carrier sense is taking place, and the channel, it will get the impression that the channel is busy. While it doesn't want to send to B, it wants to send to another node in another direction. But unfortunately, due to the omnidirectional transmission process, you are transmitting in all the direction, we will always experience hidden terminal problem and exposed problem. Therefore, nowadays in future 5G technologies and advanced wireless system, they consider using not omnidirectional antennas, but rather directional antennas. Basically, you point your transmission and focus your energy just in the direction of your receiver, so that you avoid any interference with the other nodes. So this is the hidden terminal. This is how the nodes interact with each other, and this is the request to send, the clear to send. This process solves the hidden terminal problem, but it doesn't solve the exposed terminal here. As you can see, when each node has an omnidirectional antenna and is transmitting in all the direction, we will always have these problems. Therefore, you need to use this sense, request to send, clear to send, in order to minimize collision, but still it's not gonna always work, especially if you have exposed terminal. One solid way to solve these problems is to use directional antennas. Directional antennas are antennas that are not transmitting in all the directions, but rather in certain directions with narrow beams. So you see here, you have a networking problem, but the solution for it is understanding the physical layer and understanding signals and antennas and how the signal propagates, how you can make beams, how you can make your signal propagate only in certain directions. So this is the beautiful thing about understanding different domains and connecting them in a meaningful way.